Morning, children. Today we will learn about different RDBMS operations. As you studied in your class 11th about the basics of relational database management system and the few concepts of relational algebra. Today we discuss some new concepts of relational algebra. It is quick revision of RDBMS. You all know what is RDBMS. For your ready reference, I'll tell you the definitions of RDBMS, but it is your task to write all these definitions in your notebook. RDBMS stands for Relational Database Management System, which deals with relations or tables. Relation is a table in relational database management system. Tuple, it is a row in a relation or row in a table. Attribute, these are columns in a table. Keys, these are the unique constraints which are applied to the table and which identifies each and every row uniquely. You can further bifurcate keys in different types of keys: primary key, candidate key, alternate key, foreign key. Primary key is also known as integrity constraint, which identifies each and every row in a table uniquely. Candidate keys are those keys which are candidates of primary key. These keys can be primary key and serve as primary key, but each key can't be the primary key, so you have to select only one key among candidate keys as a primary key, and the remaining keys are known as alternate keys. Foreign key is also known as referential integrity constraint. It is also known as referential integrity constraint, which is used to join two or more tables or build relationship among two or more tables. What is relational algebra? It is a procedural query language, and the whole RDBMS is based on this relational algebra. It gives a step-by-step process to obtain the result of the query. It uses following operators to perform queries. Students, we discussed all these operations in class 11th also, but these are necessary for your this chapter, and these topics are interrelated, so I am quickly revising these topics. Selection, the select operation selects tuples. Tuples means rows and satisfy a given predicate. Predicate means a condition. It is denoted by sigma. Select is denoted by this symbol sigma. Where is the symbol? This is the symbol sigma, and the notation is sigma PR, where P is the proportional logic formula or a where condition. You can understand it with the where clause. Projection. This operation shows the list of those attributes that we wish to appear in the result. Rest of the attributes are eliminated from the table. You can understand it with the help of the column selected in select tool, where you used to write select column 1, column 2, column 3 from the table name, where column 1, column 2 and column 3 are the selected or projected columns out of the columns given in a table. So you can apply projection in relational algebra also. Union. This is another operation of relational algebra. Suppose there are two relations. Relations means tables. One is R and another is S. The union operation contains all the tuples that are either in R or S or both in R and S. It eliminates the duplicate tuples. It is denoted by U. It is operator U, and you can simply say it union. A union operation must hold the following condition. R and S must have the attribute of the same number. Duplicate tuples are eliminated automatically. Now you are well familiar with the terminology. Attribute means columns. So the two tables R and S must have the same number of columns to apply union operations. Duplicate tuples are eliminated automatically. Suppose you have a table T1 and you have table T2, and you have set of values 1, 2, 3, 4 in table 1 and 2, 5, 6 in table 2. So what will be the result after union? You will get 1, 2, 3, 4 and 5. You can see that the unique values from table 1 and table 2 are extracted by the union operator. At the same time, the common value is extracted only one time. So the union operation is clear to you, I think. The next operation is intersection. Suppose there are two tables R and S. Two relations means two tables. The set intersection operation contains all tuples that are in both R and S. It is denoted by intersection. Intersection, you can simply mark it as the reverse U in your notebooks, but it is the symbol of intersection, and notation is R intersection S, means only common values from table R and S will be extracted by intersection. I have given you the previous example. Suppose the table R has 1, 2, 3, 4 and 5 values, and S has 1, 2 and 3 values. So the common values in both the tables are 1, 2, 3. So intersection will extract 1, 2, 3. The difference operator, the difference of two relations. Relations means tables. The set intersection operation contains all tuples that are in R but not in S. It is denoted by intersection. The symbol is minus, R minus S. How can you understand it? Suppose there are two sets R and S. The R is having values 1, 2 and 3, and S is having values 2 and 3. So what will be the result of R minus S? The 1, which is not present in S but in R. So the difference operation give you R minus S. Cartesian product. The Cartesian product is used to combine each row in one table with each row in other table. It is also known as a cross product. The cross product is, we also discussed in class 11th. In cross product, what will happen? Suppose the table A has 7 rows and the table B has 4 rows. So the resultant will be having 28 rows after Cartesian product. When we write SQL query for Cartesian product, we must not write the join condition. Without join condition, when we want to extract data from 2 or more tables, the operation performed is known as the Cartesian product, and in relational algebra it is denoted by cross or X. So students, I hope you understood these 4 operations: union, intersection, difference and Cartesian product of relational algebra, and they can be mapped in ANSI SQL. They are theoretically mapped in ANSI SQL. As you know, SQL is a standard structured query language which is supported by each and every database, each and every commercial database, free database available in market. We are studying MySQL as RDBMS in our syllabus. So we must know whether these set operations are supported by MySQL or not. How can we understand it? We can understand it with the help of this table. See, here I am comparing relational algebra operations with equivalent SQL queries in MySQL. See, select ename equal to Smith from table EMP. It is equivalent of this query, select star from EMP where ename equal to Smith. You can write it in relational algebra, row ename equal to Smith, in the parenthesis EMP. Pi is the next query you can see. The pi is the projection. Where pi is the projection means you are selecting only 2 columns from employee table and you can replace it with the select ename sal from EMP. Now you can understand the union also. See, pi customer name borrow means you are selecting customer name from borrow table, union pi customer name from depositor table. Now you are making union operation in relational algebra. SQL in MySQL also supports union operation. You can simply write select customer name from borrower, union select customer name from depositor. What will query do? Query will display all the customer names present in borrower as well as depositor, and the common name will be represented only once. And here see, the intersection operator, we can represent it in relational algebra as project customer name from borrower intersection project customer name from depositor. In MySQL, the direct intersection operator is not supported by MySQL, but it can be achieved using distinct and join clause. We will understand this intersection operation when we will discuss joins. Now the minus operation. In relational algebra, we can represent project customer name from borrow minus customer name from depositor. What will happen? It will print only the customer names which are present in borrow but not present in depositor. This minus operation is also not available in MySQL directly but can be achieved using left and right outer join, which we will discuss in the next video. Now the last operation, it is the cross join. Employee cross department means we are joining all the rows of both tables, which can be written in MySQL, SQL of MySQL. How? Select star from EMP comma department. It will retrieve all the data from employee and department table after joining each and every row with each other. You can simply understand these operations with the help of these images also. See, A and B are 2 sets and after union you get the result. This is the result. And here is the intersect. In A and B are 2 sets and the intersect will give you only the common values which is present in A and B both. And the minus, what will minus do? Minus will, if you have to perform minus operation, A minus B, only the values which are present in A will be displayed, which are not common in both the tables. So I hope these all operations are understood to you. And see, this is the cross join. What will happen in cross join? We are selecting food dot item name comma foods dot item unit comma company dot company name comma company dot company city from foods cross join company. Here are 2 tables. We are joining 2 tables without any condition and writing simply cross join, or you can separate it with simple comma. Here you can simple, don't write this cross join, you can replace this cross join with the comma only. So the query will also display the cross join result. So students, I think it is but clear to you, and this is the end of the class. Thank you. Hope you understood.